Hi, in this video we'd like to take a look at compound interest. Now compound interest is the following formula. A is equals to P 1 plus I to the power of n. In this case, the difference between compound interest and simple interest is that compound interest stacks on each other. So compound interest is the interest calculated on the initial principal as well as the accumulated interest from previous periods, fostering exponential growth over time. So here A, P, I all mean the same thing as simple interest, where A is our principal amount plus the interest, P is the principal amount, I is the interest gained, or the interest rate being applied rather, and n is the number of compounding terms. Notice how I don't say n is the number of years, but the compounding terms. We also have a variation of this formula that is taken when depreciation occurs. So in the case of depreciation, we have our formula A is equal to P 1 minus I to the power of n. So just to make the example, what compound gain looks like. So compound gain says this. If I make an example of boxes, let's say I get a box. If it was simple interest, then I'll get a box and another box at the end of the month. And then, or not at the end of the month, but at the end of the year. So the growth would kind of look like this. After the first year, after the second year, we'd have 3 boxes, because each year we're adding 1 box. 1, 2, 3, 4. Now we have 4 boxes. But in the case of compound interest, this is what we do. We start off with 1 box, then after 1 year we also have 2 boxes. But then on the 3rd year, since now we have 2 boxes, we count the additional box, or we consider it when calculating the amount of box for the following year. In this case, we didn't consider how many we had in the previous one. We just added plus 1 box, plus 1 box, plus 1 from the previous, right? In this case, we consider this is our starting point. Now we say plus 2 blocks. So now we have 4 blocks. And then in the next part, we'll have 8 blocks. Like this. So this is compound growth as compared to linear growth. If you were to compare these two on a Cartesian plane, what you would have is compound growth, interest, simple interest growth would look like this. It's linear, the amount of interest over the amount of, let's rather put A, over the amount of years that we are working with. Whereas, and of course it would start from the center like that. Whereas if we take a look at compound interest, it has this kind of type of growth, where at first it's a bit slow, but then over time it rises up exponentially. And yeah, this is the case of compound interest. If you were to take a look at it using money, with the same example from the simple interest, we start off with 1,000, and then our interest that we are gaining is 10%. 10% of 1,000 is 100. So here we're gonna have 1,100. But then if we wanna calculate how much we're gonna have in the second year or after the second year, we now consider 10% of this, which would be 110. So we add, to get that one we say plus 110, which will be 1,210. And then you continue with this process. You add 10% of this amount, which would be 121, and then the amount just keeps on growing. The interest grows as the money grows as well. So that is compound interest. And then I just want to mention briefly that n depends on how often this amount is being compounded. So we multiply by 2 if it's compounded biannually. But we use n as it is, so this is 2. Annually would be once Then we have quarterly, that would be 4. And then we have biannually, quarterly, annually, and that's about it. You also have monthly. Monthly, you multiply by 12, because now the amount is being compounded 12 times a year. But this means that you should also divide your interest by the same amount, since it's spread out over the year. But then this is about it for compound interest. It's just interest gained on top of interest.